Hello, this is Stephen Meadows, and I'm explaining the 24.4 combining GISC baseline vectors with traditional observations. From Chapter 23, we learned that the three-dimensional geodetic adjustment allows the adjustment for all traditional surveying observations. If the control is known in the local coordinate system, then equation 24.2 can be included in the adjustments to account for the datum differences, where x sub LD is a local datum, x sub GD is a geodetic datum, R prime is a rotational parameter, S is a scalar, and T is a translational element. The baseline vectors are the geocentric coordinate differences between 2 points. Thus, the translation component of equation 24.2 is removed, leaving only the scaling and rotational parameters. As such, the translational element can be removed, leaving these two equations. Since the three-dimensional geodetic network adjustment was performed in a local geodetic coordinate system, the rotational elements can be transformed about a single station. It is preferred that the station be centrally located within the project to eliminate propagation of error. The rotational equation is listed as such, where R sub U, R sub E, and R sub N are these matrices. And it is simplified into this equation. The three-dimensional geodetic adjustment was developed in a local geodetic system. As such, the baseline vectors must also be rotated into the same system. From Chapter 17, we learned that the coefficient matrix for each baseline vector consisted of 3 rows containing a -1, a 0, and a 1. The matrix presented in Chapter 17 must be rotated into the local geodetic system, and the coefficient matrix values are derived as such, where phi and lambda are the geodetic coordinates for I and j. The elements of the coefficient matrix for the unknown angles in the scale are j, where xt is the elements that you're looking for, and r sub n, r sub e, and r sub u are these matrices. When you put in GPS coordinates or GNS coordinates into a local system, you have to take into consideration that the conventional survey was in astronomical coordinates, and the GPS or GNS survey was done in geodetic coordinates, and you need to take into account these differences in the datums. As an example, using the appropriate information from Table 23.3, Example 24.2, and the accompanying baseline vector data, determine the non-zero elements of the coefficient j and the constant k matrices. Your baseline has a delta x and delta y and delta z in meters as shown. This is your r sub x sub g of your for station B and station E, and this is for station B for your R sub LG and for station B and E. Plug those into the equations listed here to get that to reduce down, and your values for your I, J, and J coefficients or matrices are listed as such. Thank you.